Wiley. I am a graduate student at UC San Diego, and much of my thesis work includes design and fabrication on Liger. So it's my pleasure to be here on behalf of the Liger team to give you all updates to our program. So a quick overview, what is Liger? Liger is both an imager and an integral field spectrograph, and it is being designed to take advantage of the upgrade to the Keck 1 AO, so COPPA. And on the right here is a CAD rendering of the Liger instrument. And if I remove the vacuum chamber walls and the cold shield, we can see the internal components. So I think of Liger as three main subsystems. There's the imager in the top left, and then our IFS is split into two systems. So a slicer for coarser spatial scales, larger field of view, and a lenslet for finer spatial sampling. And Liger gets its name from it being a hybrid instrument. So we take the design of the spectrograph for IRIS, which is the first light instrument for the 30-meter telescope, and we adapt it to Keck by implementing a new imager and re-imaging optics. So Liger is the largest cat in the world. So it's a hybrid of a male lion and a female tiger, and that's where we got our name for the hybrid nature of our instrument. So Liger is a facility class instrument. It provides transformative science across cosmic scales from our nearby solar system, such as observing the Jovian moons, volcanic plumes on Io, to measuring atmospheres of directly imaged exoplanets, to disentangling gas kinematics in high redshift galaxies. So Liger does it. And I'm just showing you here the galactic center science case. So this is what you would see if you looked at the galactic center without AO. So this is scene limited. And then if I start this video, you'll see the current Keck capabilities. So this is more OSIRIS with current Keck AO. OSIRIS is at a much smaller field of view than this. This is actually the Liger field of view. And Sagittarius star is a little white in the middle. And in a moment here, you'll see the improvements from when Liger and COPPA both turn on. So right there, you'll see these improvements from improved AO performance as well as sensitivity for Liger, allowing us to get closer to the high gravitational environment, closer to Sagittarius star, really opening up the capabilities of measuring in these orbits. So how are we going to do this? How are we going to build this instrument to provide this science? Well, the main update that I have is that Liger finished our final design phase and we entered our fabrication phase about a year ago in October. So this here on the right is a CAD rendering of the final design of the imager. So I am currently in the process of fabricating this. I'm making a bunch of fabrication drawings. We've ordered a lot of the optics, and we're sending them out and getting quotes and ordering them and having some of them fabricated as we speak. We also had to do a few prototypes. So I'm going to show you here. This is a 60% scale prototype grading turret. So Liger has 13 gratings, and we had to do this prototype to prove that we had the positional repeatability between switching modes. We need our spectra to fall in the detector in a predictable way every time. So we did that, we verified it, and we are currently fabricating the 100%, but not prototype the actual full science version of the grading turret. We also had to prototype our TMA, our 3-mirror anti-stigmat assemblies, because these are some of the largest optics in Liger, and they require some of the most precise alignment. So we actually have a proprietary alignment tools and strategies for these. So this again is a prototype that we sent the drawings, and the full scale TMAs are being fabricated currently. We've also made some updates on our software development. And the main things that we have currently fabricated, and some of them are already finished, are 3 new cryostats. So Liger is a very large instrument, and we have to characterize subsystems before we install it in the final science cryostat. So this here on the right is the existing cryostat that we're going to use for the imager. This exists at UCSD. It's currently operational. And yeah, that's currently in our lab. We are also currently fabricating the IFS assembly doer. This will live at UCLA, and it is currently being fabricated again right now. So this is the rolled and welded vacuum chamber for the doer, and this is the internal cold shield. So very soon, this doer will be online. And then just to remind you guys of what the full science instrument looks like, this is the Liger cryostat. So we're going to fabricate this early because we can use it to test components before we install the full instrument inside of it and align everything. So these are all currently underway, and we've also made some updates to our software development. What I'm showing you here is our simulator. We have new capabilities of being able to simulate raw frames. So Liger uses an end-to-end data simulator. We include a Zmax model. We could simulate kappa AO performance. The image I'm showing you is just an example raw frame with a corresponding reduced data cube. So the lenslet is the top left and the slicer is the top right. And we've made some work on our data reduction pipeline. So the main update on that recently is we've decided to base our framework on JWST ST pipe. So I've used this simulator to update our sensitivity curves. So the main thing to get out of here is we're sensitive from 0.8 to 2.4 microns, increasing from left to right. And then your sensitivity is increasing from the top as you go down. On the left is for coarse spatial scales, and on the right is more fine spatial scales, and these are compared to other world observatories. So Liger is the solid green line here. And the main takeaway is we extend to bluer wavelengths. We go down to 0.8 microns Z-band, which other instruments don't do. And we also have comparable performance to JWST, which is this dashed black line in the bottom. We overlap in the H band. And then if you look over here on the right, the solid green lines again are for Liger. This is for the fine spatial scales. And JWST doesn't go this fine, so there's nothing to compare to. And you can see the other instruments. So just a comparison to OSIRIS, it's hard to see, but it's one of the other dashed lines above. So we're getting really great improvements in sensitivity. And this is just for the RF 4000 case. So we have RF 8000 and RF 10,000 modes. This is our activities and timeline. So just to reiterate, Liger has finished its final design phase and entered its fabrication phase, and we anticipate science release for 2029. Our project scientist is Tucker Jones, and he requested that I leave the slide up and ask any of you if you're interested in joining the science team, please contact Tucker. Here's his email, and I will leave this up and take questions. Thank you.